Let's take a look at this question. We are supposed to find the inverse of this matrix using elementary transformations. And what kind of a transformation would you like to use? We'll use row or column. We have been using alternate transformations, and initially we had also discussed the process of row and column transformation. So for this particular matrix, we'll use column transformations. Okay. Let us call this matrix A. Let's call this matrix A. And in case you're wondering, column transformation would imply that I has to be written as a post multiplier. Since this is a row by column multiplication, I has to be written as a post multiplier, which implies this is 4, 5, 3, 4, which is equal to A times 1, 0, 0, 1. Now the important thing is we're supposed to convert this into an identity matrix. We'll apply column transformations. Let's convert this into a 1. C1 is replaced by C1 divided by 4. What does it give me? This is 1, this is 3 by 4, this is 5 and 4, they remain as it is. This is A, this is 1 by 4, this is 0, this is 0, this is 1. That's what we have, right? What else? You have converted the first element, first row, first column, this into a 1. What next? After, when you are applying column transformations, once you have converted this element, cover the first row. So this 5 has to be converted into a 0. Let's do that. So C2 can be replaced by C2 minus 5 C1. 5 times 1 can be subtracted, and what will that give us? That will give us 1 and 3 by 4 remain as it is. 5 minus 5 becomes 0. 4 minus 5 times 3 by 4. 4 minus 15 by 4. 4 minus 15 by 4. You take the LCM, it becomes 4. 16 minus 15, that is 1 by 4 over here, which is equal to A times. What about the RHS? In the RHS, C2 minus 5 C1. C1 remains as it is, 1 by 4 and 0. This minus 5 times this, okay, this becomes a minus 5 by 4. Pretty simple, 1 minus 5 times this becomes this. Okay, C2 minus 5 times C1. Okay, what next? Once you have reached this stage, then this can be converted to 0 or this can be converted to 1. Okay, let's try to convert this into a 1, very easy, yeah. So, C2 can be replaced by 4 C2. What does that give me? 1, 3 by 4 will remain as it is. This becomes 0, this becomes 1, which is equal to A is okay, 1 by 4 and 0 are also okay. This becomes minus 4, minus 5, this becomes 4, right? Multiplication with 4. C2 is replaced by 4 C2. Once you have 1 over here, we can convert this into a 0, right? Very easily. C1 is replaced by C1 minus 3 by 4 C2. This has to be multiplied with 3 by 4 and subtracted. So what does that give me? This is 1, 0, this becomes a 0, this is a 1 over here, right? Which is equal to what? Which is equal to A times, matrix A times this matrix over here, C1. C2 remains as it is, this is minus 5, this is 4. And what you have in C1 is 1 by 4 minus 3 by 4 times this, okay? 1 by 4 add minus minus will become plus. 5 times 3 by 4 is 15 by 4. 1 by 4 plus 15 by 4 is 16 by 4, which is 4. Next, 0 minus 3 by 4 times this. 0 minus 3, which is minus 3. That's what I'll get. Therefore, A inverse is equal to 4 minus 5 minus 3, 4. This is what I get. 4 minus 5 minus 3, 4. This is what I get. And when you are asked to find the inverse, always verify. So let's check. A inverse, the product A inverse is equal to, the matrix A is 4, 5, 3, 4. And the matrix A inverse, that's what we have found over here. This is 4 minus 5 minus 3, 4. This is the matrix over here. What else? We'll multiply these two matrices together and let's see what you get. This is 4, 4, 16 minus 15, which is 1, minus 20 plus 20, which is 0, plus 12 minus 12, which is 0, minus 15 plus 16, which is 1. This is the identity matrix, and yes, the answer that we have obtained is correct. The inverse matrix that we have obtained, this is my required answer for this question over here. This is 8th part? Yeah, this is the 8th part.